Hello and welcome. In this video, we'll solve Z transform example number 3. Please watch previous video so that you can understand the concept of Z transform and its ROC. Let's start. The question is find the Z transform of sequence x of n is equal to 1, 2, 3, 4. Here the position of arrow is here, means this is the position n is equal to 0 amplitude. So n is equal to -1 here, n is equal to 1 and 2 here. Let's draw the sequence first so that you can understand. N is equal to 0 is here, means at n is equal to 0, amplitude is 2. At n is equal to 1, amplitude is 3. At n is equal to 2, amplitude is 4. N is equal to 1, amplitude is 3. N is equal to 0, amplitude is 2. And n is equal to -1, amplitude is 1. Now let's find Z transform. We know definition of Z transform is x of z is equal to n varies from -infinity to infinity, x of n z raised to -n. Now check your x of n. It exists only for n is equal to -1 to 2. For other values of n, your signal is not there, means its amplitude is 0. So the limits of n is only -1 to 2. Let's put it -1 to 2 x of n z raised to -n. Now put the values of n. N is equal to -1, 0, 1, 2. N is equal to -1, x of -1, z raised to minus of -1. That means it becomes +1. N is equal to 0, x of 0, z raised to 0. N is equal to 1, x of 1, z raised to -1. N is equal to 1 here. That's why -1. And n is equal to 2, x of 2, z raised to -2. Now put the value of x of -1 is 1, x of 0 is 2, x of 1 is 3 and x of 2 is 4. Now concept of ROC. ROC means what? Your x of z should be finite for which values of z. Now if you check here, if I put z is equal to 0, what happens? This becomes 0. It's okay. This becomes 2. Now here z upon 1. If I put here 0, 3 upon 0 is infinite. So it becomes infinite for z is equal to 0. Now let's put z is equal to infinite. Z is equal to infinity. So here it becomes infinity. 1 upon infinity is 0, but here z is there. Due to this z, x of z becomes infinite at z is equal to infinity. So here we can say that for z is equal to 0, 0, 1 upon 0 is infinite and z is equal to infinite, this x of z becomes infinite. And for other values of z, this x of z is finite. So ROC is entire z plane except z is equal to 0 and z is equal to infinite. Entire z plane means all the values of z except z is equal to 0 and z is equal to infinite. This x of z becomes finite. So ROC, let's draw it graphically. Z plane, real part, imaginary part, entire Z plane, except Z is equal to 0. How will show? By circle at the center Z is equal to 0 and Z is equal to infinite. Let's put a bounding box to this entire Z plane to indicate Z is equal to infinite. Based on this, we'll define third property of ROC. Property is if x of n is finite duration, both sided, then ROC is entire z plane except z is equal to 0 and z is equal to infinite. Let's understand. Finite duration, what is our x of n? Only 4 samples, means it has a finite duration. Then both sided, so it exists for n is equal to 1 to right side and left side, n is equal to -1. So left side also and right side also. That's why both sided. If you check the previous example, in the first example it is right sided. It exists only for positive values of n. In the second example it is only left sided. It exists only negative values of n. Now here it exists for positive values also and negative values of n also. That's why it is both sided. So for this type of sequence, ROC is entire Z plane except Z is equal to 0 and Z is equal to infinite. That means any sequence which has finite duration and both sided, its ROC is entire Z plane, all the values of Z except Z is equal to 0 and Z is equal to infinite. So this is about the Z transform. Thank you.